RDS Aurora, the AWS Cloud Native Relational Database, offer an easy integration with multiple other AWS services. Among them, AWS Lambda. AWS Lambda is an event-driven compute service that lets you run code without provisioning or managing servers. It's available for use with many AWS services, including Aurora PostgreSQL. For example, you can use Lambda functions to process event notification from a database or to load data from files whenever a new file is uploaded to S3. In this demonstration, we will explore the first use case. I'm Yann Alandi, Database Solution Architect at AWS. Let's imagine you need to audit the data modification language or DML activity from a table. You can use AWS DMS, Database Migration Service, for migrating the data either in bulk mode or in change data capture mode. You can use Aurora Database Activity Stream for auditing the queries run against your database. However, none of these solutions will offer a full audit, including the collect of the query as well as the data image before and after. This is where triggering Lambda from Aurora will help. Here is the architecture I'll demonstrate today. An event table is stored in Aurora PostgreSQL. A trigger function will invoke AWS Lambda in case of DML action on the table. Lambda will write the activity to Amazon SNS for simple notification service, which will deliver the message to any subscriber. Note that the Lambda target is very flexible. It may be a Kinesis pipeline, a table in another RDS database, and so on. So let's switch to the console and check the environment by now. So here we are. We do have an Aurora Postgres database. Described here we are using for this demonstration, and what we can see is we have some security rules at the bottom, like accessing from another subnet, so meaning that the database is running into a private subnet, and we have an outbound connection for getting a NAT gateway, but I will describe that later. If we look at the configuration, we can see that the engine is a 15.4, and we are using also the default parameter group as well as option group into here. Now, let's look at the Lambda function. We have here my RDS trigger topic writer, which is the Lambda function we are using. You will see here the code. I'll not spend that much time on the source code of the function because this is something that will be provided at the end of the presentation. You will get the link, and into the link you will see the content exactly of the code, so you can just cut and paste if you want to rerun. If we go to the configuration tab, not that much here, but at the permission level, we have some permission and rule based in order to invoke the connection and allow the connection between the services from RDS to Lambda and from Lambda to SNS. And we have also CloudWatch permission for writing events. We have also the environment variable, which is needed for our code, where we provide the RN value for the SNS topic. So talking about the SNS function, let's switch to it. And it's very simple one, right? We have this my RDS trigger topic, which is just SNS feature. And at this point, I have one single subscriber who will receive the message post into SNS. Now, let's look back to the network. So we have a VPC dedicated for this demo. Within the VPC, we have 4 subnets, 2 private, 2 public. The public are obviously connected to an internet gateway, and the private are connected to a NAT gateway, but cannot be reached directly from outside the VPC. If we look at the security group we are using for the database running in the private VPC, we briefly seen already the content, but let's double check. And it's here. We have inbound role. We allow access from the public group where our jump station is running, allowing access directly to the database. And we also allow access from HTTP because of the Lambda access. And in outbound, we allow traffic to 0 for the gateway. And finally, something which is important, the IAM roles we created. So let's look for my RDS. So we created 2 roles, one RDS Lambda execution policy. And if we look at the policies associated, here we are allowing our RDS database to invoke Lambda, right? So this policy or this role is associated with our RDS database. And we have another one. RDS, which has 3 roles. The first one is the AWS managed role, which allows Lambda to access the VPC. And then we created 2 other policies associated to this role. The first one allows the Lambda function to write to create log stream in CloudWatch. And the second one is to allow the Lambda function to write to SNS. And here we have the RN for our SNS topic. Right. So this role is associated with our Lambda function, as we have seen. So this is it for the description of the environment. Let's move to the demo itself and see what happened in action. So we are now connected to our jump station, which allows an access to the RDS Aurora database. And from here, I'm using PLSQL to access our MyDB1, which is the DB where our demo environment is running. So here I have a single table I'm using for this demonstration. The table is called Customer Business Event, and here is the description of the table. So we have like 5 columns. The name and the type is not that important, but what we can notice is there is a trigger associated to this table, and the trigger is triggered every time there is an insert, a delete, or an update. And it will call a function called myDBTrigger function every time for every row affected on the table, right? So if we look at what is inside our database, so let's run a select star. Inside our table, sorry, not database, we have like 7 records. So fairly short. Let's insert a new data. So I recall one of the commands I run. And we have, let's insert 2007, missing, and as an error, say missing name. So we insert a new record into our tables, and we can see that the trigger is enabled right after the execution. And if we look at what is inside our table, we have now a new record 2007 missing name. It means we generated one event. What if now I update this table? So let's find in my history an update command, and what I will do, I will change the record which has ID 2002, and it will become a 2010, and the application will be reference system instead of customer onboard app. Let's run this one. Here again, the trigger is enabled, is triggered, and it will call the Lambda function and send a notification. Let's just check what is into our database. And we can see that there is no 2002, but we have a 2010 instead, and there is a reference system associated. Okay, so this is what we did into our data. So now what we want to know is if any event was published into SNS, and if we received an email from this modification. So let's go to my mailbox, and I can see that I received at 5:03 today a record saying, there is insert into customer database an event with value 2007. Right? This is the query, text query. I run, and I can see that the value for each and every column are listed here. And then I received another notification where I can see that the text query was an update, right? ID 2020-2002. And we have the old data and the new data reported here. So as a conclusion, really, if you want to audit the queries run against an object into your Aurora database, and if you want to get the history of the old and new value reported somewhere, you can rely on Lambda integration with RDS Aurora and select the target you want. Here it's SNS, but it can be anything. Just for the record, there is one thing I would like to share with you, which is the code of the function we trigger every time there is a DML event on our table. So let me show you. And here is the function. So as you can see, it's a function returned as a trigger. We have some variable. We collect information like the current query, like the user ID. And this is what we send as information to Lambda, right? And this is converted in JSON. And yeah, that's it. As a summary, Amazon Aurora is natively integrated with AWS Lambda. It's ideal for an event-based architecture. It allows near real-time event tracking and notification. It is a scalable solution, and you pay for the consumption only. Thank you for watching.